This lesson is going to talk about dilations, and you're going to want to take notes on some of these things, and I'm going to do several examples, so work through this. But one of the things we're going to need to know how to do is to solve proportions, proportional reasoning. So if we have 3 over 5 equals a plus 5 over 25, to solve a proportion, the way we do this is we cross multiply and set them equal to each other. That's 25. So 3 times 25 is equal to 75. And then 5 times a plus 5. Now we could distribute this, but we could just divide both sides by 5. So we get 15 equals a plus 5. Subtract 5, and so a equals 10. That's how you solve a proportion. You cross multiply and set them equal to each other. Another way to solve a proportion, if you had like 3 over 4 equals 6 over x, you cross multiply 6 times 4 and divide by the opposite. So 6 times 4 divided by 3, 24 divided by 3 equals 8. So x equals 8. You're going to need to use that several times, proportions, in this lesson. So we're going to be talking about dilations. A dilation is written in this notation, where it's D and then Q right here is the center of dilation. So the letter that they use is the center of dilation. They might choose T, they might choose V. There will be different letters there, but that just denotes where the center of dilation is. And then N is the scale factor, what we're multiplying in order to get the new point. So if you notice right here, QP, so if I have Q and I go out here to a point P, and if I dilate it, if I go out to this new point here, we're going to call this P prime. If you have this little notch by the P, that's called P prime. And the scale factor is always N times QP. But if we wanted to just find the scale factor, if we knew QP was 3 and P prime was 6, and we wanted to find the scale factor, what we would do is we would say the whole thing is equal to 9. You're going to have to add those segments a lot. So QP prime is equal to 9, and that's equal to the scale factor times just QP, which is 3. And to solve, we just divide. And so the scale factor in this case would be 3. Make sure you need to do the whole thing divided by this. So write this in your notes. You've got QP prime divided by QP is equal to the scale factor. So whenever you're working with scale factors, you take the dilation, the center of dilation, to the prime, the one with the hash mark, over the center of dilation to the original. And that's going to give you the scale factor. So a dilation is going to move each point other than that center of dilation a specific distance based on the value of n. So if I were going to create a line here, let's call this R. And I'm going to change PR, and I want to know what P prime R prime is. Well, if I'm dilating this the same way, and let's say R is 3.5, well, how do I find out what QR prime is, or even what R to R prime is? Well, we can set up a proportion. We would say, we know that our factor is 3, our scale factor is 3, so what we have to multiply 3.5 times 3, which is equal to 10.5, and that is going to give me the whole section. Right there is 10.5. This is kind of hard to see. That whole thing is 10.5. If I needed to just find this spot, then I would have to find 10.5 minus 3.5, and this section would be 7. So you've got to look at the whole thing over the original in order to find different things. So there are 2 different types. The scale factor is either going to be a reduction or an enlargement. A reduction is if n is between 0 and 1. So if it's a fraction or a decimal less than 1, you're going to have, notice our prime is smaller than the original. It's actually closer to the dilation. In this case, our dilation point is C. So that's a reduction. Enlargement means it's bigger. So our scale factor is going to be greater than 1. If our scale factor equaled 1, well, if the distance here, let's say this is 5 units, well, if we multiplied 5 times 1, it would still be 5 units. So it's not going to change at all. So if it's greater than 1, this scale factor is going to be bigger. It's an enlargement. So here's some key concepts. You might want to pause and take some of these notes down. But these are the things. A dilation changes the size of the figure. It does not change the ratios. It does not change the angles. So angles are the same. So A is still congruent to A prime. The angles are the same if you've got a whole figure. And enlargement increases it by the scale factor. So if we're going to enlarge A to A prime, remember our scale factor is going to be QA prime over QA. In this case, it's 1.5 because we have to add the whole segment over the original, which is 1. And 1.5 over 1 is just 1.5, and sometimes you'll see them written as fractions. So 1.5 as a fraction would be equal to 3/2 is the scale factor. Either one of those are correct, but just so you know, if you find something that's a decimal and your only answers are fractions, you need to change it to a fraction. So that is the enlargement, is when we're taking a scale factor. So the reduction is it reduces it by a scale factor, so it's going to be smaller. If we were going to reduce ABC, then we would have a triangle in here that would be actually smaller. So it tells, the scale determines, here's those same things. Between 0 and 1, it's a reduction, and greater than 1 is an enlargement. So in this case, we found our scale factor is 3/2. And then if we had other points, like we could check those as well. So in this case, when we are looking at this line and this line, we take the prime, C prime, B prime, over CB would give us the scale factor. In this case, it's 3/2, which is the same thing that we found the other way. So let's do a little practice here. Line WY, here's our original. Line WY is dilated to create this new line, W prime, Y prime, with Q as the center of the point of dilation. So what is the scale factor? Well, remember we have to take what we know. We only know these sections up here. So we know that 2 plus 3.5 equals 5.5. So QW prime over QW is going to give us our scale factor. So I do 5.5 over 2, and I could just put that in my calculator and I get 2.75 is my scale factor. So now it says if we know that QY prime, meaning this whole thing is 4.125, what is QY? So in this case, we just want to find this little section. Well, again, we're going to use the same thing. We're going to say QY prime is 4.125 over QY, which we don't know, is equal to 2.75. And this is a proportion. We can set that over 1, and we can cross multiply and divide. So 4.125 divided by 2.75. And that is going to equal 1.5. So that would be the length of QY. So if we're reducing a segment, segment AB is called the preimage. That's another word you might want to know. Preimage is what we start with, and to produce the image is what the new dilated portion is. So if we're trying to find the scale factor, we take the image, or image over the preimage, and so that would be 1.25 over 5, and if we figure that out, we end up with 1/4, which is the same thing as if we did up here, 1/4, CB prime over CB. So that's another way you're going to hear it as preimage and image. So if we take a look at this, if we have, this is the rule, DQ 2/3. Remember, Q is our dilation point, our center of dilation, and this is the scale factor, or our N. So the center of dilation is Q, and it's telling us our dilation factor. So what is the distance from the center to A? So we're going to take a look. We're going to have some figure in here where we're going to have A prime, B prime, and C prime. And we want to know the distance from C to the image of vertex A. So Q, we want to know this part right here. Well, we know the whole thing is 6, and we multiply it by our dilation factor, and that 6 times 2/3 is equal to 4. So our center, our image, is going to be 4. Okay, figures that are not dilations. The sides must be proportional and the angles must be congruent. So these are examples of what they are not. Not proportional and not congruent are not dilations. So let's determine whether this is a dilation or not. So first thing we take a look at is we look at the proportions, and we have 3, right here 3, and then we have 3 plus 3 is 6. So we have 6 over 3, or excuse me, that's 3 over 6. And is that equal to, and in this case we have 3 over 9. Well, that's 1/2 over equal to 1/3, and that is not a dilation because they are not proportional. So that's how you tell. So I want you to pause the video and try this one on your own and come back and check. So in this case, we're taking our S prime Q over SQ, 8 over 4 equals 2. Remember, we take the whole length over the preimage, and we're going to get our scale factor. So in this case, a triangle is dilated by a factor of 1/3. Well, what do we know if that's true? Well, if it's between 0 and 1, it is a reduction. That's what we know is true. Okay, pause the video and try this one. In this case, we're given one of the lengths and the scale factor. So all we need to do is we take our original length, multiply it by the scale factor, and we get the length of the new segment, which is 6. So if a rectangle is dilated by a scale factor of 1, what's true? Remember, if it's 1, then they are going to be the same image. The image will be congruent because it will be, if we multiply anything by 1, you get the same side. So if a side is 5 and you multiply it 1, the new side is also going to be 5. So they will be congruent. So let's take a look. Here's a rectangle that's dilated. It's using the rule dP3. So this is telling me that P is my center of dilation and 3 is my scale factor. So pause the video and see if you can find the correct answers for this one. So one of the first things you'll notice is it gives us the scale factor here. So the scale factor is 3 is our first correct one. And then to find the length, we just multiply our image by 3. So we get this is 18 units. And because it is larger and the scale factor is greater than 1, it is an enlargement. All right, here's another one. Pause the video and see if you can figure these ones out. All right, this has lots of parts to it. So the first part I did in blue. We know that angles are congruent in the dilations, but we don't know angle B. So we first have to find angle B by adding 34 and 51 and subtracting it from 180. So we get angle B is 95, and so B prime, C prime, B prime, B prime also has to be 95. Then we're given up here that the scale factor is 1/2. Well, we know that 1/2 of CQ has to equal 3. So we multiply both sides by 2, so we get CQ equals 6. And then we're given BD is 22, scale factor is 1/2, so we just take 22 times 1/2 is going to give us 11. All right, pause this and see if you can find the scale factor. The important thing to remember when you're doing a scale factor is you've got to take the whole length, OA, I put Q, but it's the same, OA prime over OA. So 12 over 3 is equal to 4. Make sure you do the whole thing divided by that segment. So let's find the missing distance. Why don't you pause the video and use what you know about scale factor and what's been given to find the missing distance. Okay, I'm going to show you 2 different ways to do this one. Because we're looking for this section right here, we can do it in one of 2 ways. The first way is we take the whole thing. So we take our whole proportion. We've got 2.5. So we take 4 times 2.5. That gives us 10. We multiply our original section by the scale factor, and it gives us the scale factor right there. And then to find x, we just subtract. X equals 6. The other way you can do it is because sides like this, they are proportional. So if we put 4.8 over 3.2, that is equal to x over 4. And if you cross multiply and divide, you're going to get 6. So you'll get the same answer either way. There's just 2 different ways to do it. All right, pause the video and see if you can find this one. In this example, you need to find the scale factor first. So I take my whole thing, 42 plus 12 is 54, divided by 12, I get 4.5. Then I multiply each side to get the dimensions, 18 by 27, and then I get the area by multiplying those together. Okay, pause the video and try this one. All right, you should have got 2/5. Remember, you take AV prime, which is 3.2, over the whole segment, and simplify it. 0.4 simplifies to 2/5. Okay, pause and try one last one. In this case, we're given the scale factor, so PG prime over PG equals 1/6. We can cross multiply and find that PG equals 3.